Okay, example one, we're going to be using the quadratic formula to solve a quadratic equation. We've already learned how to do it by factoring. We've already learned how to do it by completing the square. This is just another technique you're going to learn how to do. And I'm going to give you a heads up, this will be your preferred technique. You're going to like this one the best. Pretty straightforward. It gets you the right answer 100% of the time. It works every single time. The reason completing the square is taught before this technique is because completing the square is necessary for other purposes. So learning the skill is an important part of math. All right, so that's why we learned it. That's why we're going to continue to use it when asked. Okay, for the quiz that you will be taking tomorrow, if you were not quarantined and you have taken the other quiz, will involve completing the square. You cannot use this method on tomorrow's test. You must use completing the square or factoring. Those are the only two valid techniques on tomorrow's quiz for solving a quadratic equation. For future quizzes and tests, you can use whichever technique you want to use anytime you want to use it. This is one test I'm going to require either factoring or completing the square as the only valid techniques for solving a quadratic equation. Okay, those of you who are in quarantine, you'll be taking this test several days later, towards the end of this week or beginning of next week. We'll figure out a time that works for everybody. And you'll be under the same rules. You have to use completing the square or factoring, not the quadratic formula.
I was gone 2 days last week.
Okay.
And I didn't go check my study guide at all.
Okay. Study guide video is on the Canvas page, so go there to check your study guide. The practice test will be something you need to try after that.
Okay.
Okay. So, example one, solve 3x squared minus 4x minus 9 equals 0 using the quadratic formula. This is how the quadratic formula is evaluated. The formula itself is the very last line. The x equals negative b plus or minus the square root of b squared minus 4ac over 2a. That's what it is. That's just the formula. That tells you the right answers to any quadratic equation anytime you feel like it. The values of a, b, and c are the same a, b, and c we've been working with in other techniques with things like the vertex formula for a parabola, those types of things. Same a, b, and c we worked with on those. Okay, and I tell you what to do, and then you do that, you get your answers. But the first thing, the very most important thing, if you're going to use the quadratic formula, is structure. You have to make sure the structure is right. This is what the structure should be. If your equation looks like that, you're good to go. If it doesn't, you have to modify it. You have to move it around. So, 3x squared minus 4x minus 9 equals 0 is exactly how it's supposed to look. So it's in the right structure. It's ready to go. Okay. If it were not in the right order, ready to go, you'd have to rearrange it so it was in the right order. Something squared, something x, some constant equals 0. That's what it has to look like every time. A, B, and C are the numbers in front of x squared b, or in front of x squared x and the constant. And whenever you see a structure that has positives in it, positive ax squared, positive bx, positive c, that simply means whatever signs you see in the picture are the right signs. So this says 3x squared, that means a is equal to 3. This says negative 4x, that means b is equal to negative 4. This says minus 9, that means c is equal to negative 9. Everything we evaluate in this process is going to be based on those three numerical values. A is always a number, B is always a number, C is always a number. There are no x's in this, it's just the numbers. If either x squared or x has no number in front of it, there's a 1 in front of it. Okay, so there's, again, A, B, and C are always numerical values every single time. Now, this tells me to evaluate negative b. This is easy. Negative b means change the sign of b. What is b?
Negative 4.
So negative b is?
Positive 4.
Positive 4. That's all minus b is. Change the sign of b. Whatever b is, make it the opposite. 2a. All 2a means is take whatever a is and make it twice as big. What's twice 3? 6. Those are easy, right?
6.
Now let's go to the one that's a little bit more challenging, but still not that hard. We have b squared minus 4ac. Now I'm going to make one quick note here. B squared, this guy here, is always positive.
So?
Always positive, no matter what b's value is. If b is negative, you're doing a negative times a negative makes a positive. If b is positive, you do positive times positive is positive. B squared is always positive 100% of the time, and usually pretty easy to do in your head. What's 4 squared? 16. 16. Don't write 4 squared, write 16. Whatever b is, square it. And don't even worry about the sign because it's always positive. 4 times 4 is 16, that's what b squared is. If you write 4 squared or negative 4 squared, all of a sudden you got to do a square, evaluate that before you do the other stuff, it gets in the way. It's much more useful to just take whatever b is and multiply it by itself, write that down immediately. Don't write negative 4 squared. That gives you an opportunity to mess up. Then it says minus 4ac, minus 4 times a times c. This 4, this right here, is a magical 4 that's part of the formula. There's a reason the 4 is there. I'm not going to go through the reason right now because it confuses people. But after you've learned this technique and you're good at it, I'll show you where the 4 came from. But I promise it's always there. It's part of the process that was used to make the formula. If I tried to introduce that to you right now, it would confuse you. I don't want to confuse anybody. So just believe that the 4 is there, I promise. Also, notice that it says in the formula right here, it says minus. Very clearly says minus, right? And you can see right here, I wrote the minus sign. Minus 4. A is positive 3. C is negative 9. This is always a product right here. Always a product. And it's always minus in the formula, but minus is allowed to change to plus if the signs allow it to happen. It might stay minus if the signs allow that to happen. It's either going to be minus or plus. It's up to you to determine what. When I'm multiplying 3 numbers like this, and 2 of those numbers are negative, that's going to become a positive. So this minus sign can transform to a plus sign if the product makes it happen. Multiplying 2 negatives makes a positive, so minus minus becomes plus. 4 times 3 is 12 times 9 is 108. 16 is 16. So you're squaring b in your head, you're doing 4 times a times c, getting the right plus or minus in front of it, right? And then you simply add those 2 results or subtract depending on the sign. These signs are the same, so I add. So I've evaluated negative b, I've evaluated 2a, and I've evaluated b squared minus 4ac, completely down to a single number for each thing. The last thing to do then to evaluate this to get the answers you create this structure right here. Notice it is one thing plus or minus the square root of a second thing all over a third thing. And that's these 3 things we just found, right? Minus b is right here. 2a is right here. And b squared minus 4ac is right here. I'm just going to fill in those 3 positions with those 3 numbers we just found. So I'm going to put my 4 right here. I'm going to put my 124 right here. And put my 6 right down there. Sometimes we're done at this point. It depends on the square root, how well the square root simplifies, if the square root simplifies. 2 ways to simplify the square root. You have the basic one where you have a perfect square. Square root of 25 is 5, square root of 64 is 8, square root of 16 is 4, right? Then you have like this, where square root of 124 isn't one on that list, right? 121 is 11 squared, 144 is 12 squared, so that's not a perfect square. But if I did a factor tree, we're looking at the square root of 2 times 31. A pair of 2's inside gets to pull 1 2 outside. That is the right answer, but this is a better right answer. 4 plus or minus 2 times the square root of 31 over 6. Anytime you can simplify a radical, you should. Every single time you can, you should. Continuing on with the best answer possible. Again, this is right. This is better. Okay, for best, we have 3 pieces. Piece 1, piece 2, piece 3, and the square root of 31 is part of piece 2, but we don't worry about that when we're doing this. Just worry about the pieces that aren't the square roots. So, 4, 2, and 6. Can we all see they're all even? They all divide evenly by 2. So the best answer is going to be x equals divide by 2, divide by 2, divide by 2. That's the best answer. Reduced completely. Radical simplify completely. That's how you do the quadratic formula. Again, it works 100% of the time. You identify a, b, and c. You evaluate negative b, 2a, and b squared minus 4ac. Put them where they belong and reduce and simplify as much as possible.